All right, so this is going to be our last video. So if you have no idea what's going on still, I invite you to ask a question for some clarification. All right, so Nadine and Felipe picked marbles out of a bag. The results are below. So once again, we see a table. So this is experimental probability we're dealing with. So you need to add up how many times Nadine pulled stuff out of a bag. You need to add up how many times Felipe pulled stuff out of a bag. So it looks like the total here is 12, and the total here is 240, 83 plus 78 plus 79 equals 240. Yeah. All right, so all of these are going to be over 240. All of these are going to be over 12. So see if you guys can use the chart to fill out what's the probability of Nadine picking red, yellow, and blue, and then use the chart for Felipe's experimental probability. What did he get for red, yellow, and blue? And then I want you guys to tell me the theoretical probability of picking red, yellow, or blue. Okay. So how many colors are there total? There's 3. There's red, yellow, and blue. And then what's the probability of picking a red? What's the probability of picking yellow? What's the probability of picking blue? Remember, it's theoretical. It's not the actual experiment. So is Felipe or Nadine's experimental probability closer to the theoretical probability? So you need to write the theoretical probability of each next to them. So it's going to be over 3, over 3, over 3, be over 3, over 3, over 3. I want you to look at them and see how they compare. That one's kind of hard. So if you can do all of the work and not answer that question, that's fine. All right, the next one says a dartboard has 20 equal sections, 10 of which are orange, 5 are green, 3 are blue, and 2 are red. Okay, so that means there's 20 sections. That's our theoretical 20 sections. So you need to fill out how many are orange, how many are green, how many are blue, how many are red. And then we have the experimental probability chart. He threw 50 darts, and here are his results. So if he threw 50 darts, that's all of these are going to be over 50. And you're going to use the chart to fill in the probability of orange, blue, green, and red. And then I want you to answer the question, how does the theoretical probability of orange and the experimental probability of orange compare? And then you're going to tell me which one's bigger. Actually, you can just answer. You don't need to answer that. Just tell me, how do they compare? Which one's bigger? The theoretical probability of orange or the experimental probability of orange? The next one, Kim's class conducts the same experiment. The results are 116 red, 121 blue, 124 black, and 119 green. Complete the probability model below. Now, remember, probability models, we have red, so that's an outcome. We have blue, that's an outcome. We have black, that's an outcome. And we have, not 119, we have green, that's an outcome. So tell me the totals for each of those colors, and then tell me the probability. It's experimental, so it's going to be, you're going to have to add together all of you're going to have to add 116 plus 121 plus 124 plus 119. So I think it ends up to be over 480. So all the probabilities are going to be over 480. And then theoretical probability, that's how many total colors are there. Then what's the probability of picking a green if you just pick one time? And then you're going to rewrite your experimental probability down here. Okay. So that's from the totals. Then I want you to compare the theoretical probability of green to the experimental probability of green. Okay? That's all I want you to do. I know it's a lot of steps, but just take it little by little. The next one, Heidi spins the spinner shown. She records her results in the line plot. Okay, so the line plot is our experimental probability, and we have 20 total x's here. Okay, so these are going to be over 20. And so the way you read this is you look at the 1, and it has how many x's? It has 1, 2, 3, 4 x's. So that means you're going to, that means the probability of picking a 1 is 4 over 20. Now, theoretical probability, you're going to use the spinner. Look at that. How many numbers are on it? What's the probability of picking a 1? There's 5 numbers. What's the probability of picking a 2, a 3, a 4, a 5? And then I want you to tell me, how does the theoretical probability of 2 and the experimental probability of 2 compare? So you're going to have those two fractions that you get from these charts and compare them. All right. So we're looking at theoretical probability of a dice throw. So how many sides are on a dice? There's 6. What's the probability? You'll pick 1. You'll roll 1. How many 1s are on the dice? Experimental probability, you're going to have to add up all these, and that's going to be your bottom number. And then once you do that, you're going to write all the probabilities and then tell me how the theoretical probability of 6 and the experimental probability of 6 compare. So you'll have two fractions, you're going to compare them. Oops. I lost. Oh, there it is. All right, moving on to the next one. This one. So Amanda used a standard deck of 52 cards and selected a card at random. She recorded the suit of the card she picked and then replaced the card. The results are in the table below. So to do experimental probability, you need to add up all these. So we have 7 here. So the experimental probability of diamonds is 7 over something. Experimental probability of hearts is 9 over something. 5, 10, 11 over something for spades, and then 3 over something for clubs. So we need to add 7 plus 9 plus 11 plus 3. 7 plus 9 plus 11 plus 3. So it's 30. It's over 30. So 3 over 30 for clubs, 11 over 30 for spades, 9 over 30 for hearts, 7 over 30 for diamonds. Now you need to tell me the theoretical probability. So, theoretical probability, you need to know that there's 13 diamonds and 13 hearts, 13 spades, and 13 clubs in a deck of 52 cards. So it's going to be over 52 for theoretical. So based on her results, what's the experimental probability of selecting a heart? So experimental probability, that's over 30. What is the theoretical probability of selecting heart? That's going to be over the total number of cards. So there's 52 cards. What's the probability she'll select a heart, theoretically? Based on her results, what's the experimental probability of selecting a diamond or spade? So you're going to add together the experimental probability of diamonds and the experimental probability of spades. And then what's the theoretical probability of selecting a diamond or a spade? Again, you add together the theoretical probability of a diamond and the theoretical probability of a spade. And the last part you can just skip. Okay, this one I'm just going to read. I'm going to see if you guys can do these next two slides on your own. How am I doing on time? Oh, I'm okay. So, Davy conducts a poll about the election for mayor in her town. She asks voters whether they plan to vote for the current mayor, against the current mayor, or if they are undecided. The results are in the table below. Based on her results, what's the experimental probability of voting for mayor? For the mayor. Not against or undecided. What's the experimental probability of voting for the mayor? Remember, experimental probability, that you can find that in the table. What's the theoretical probability of voting for the mayor? So how many choices do you have? And then based on her results, what's the experimental probability of voting against the mayor or undecided? You add those experimentals together of undecided and against. What's the theoretical probability of voting against the mayor or undecided? So you add together the theoretical probability of against the mayor and undecided. And the last part, you can just skippity doo dah. And next one, Dave and Rachel and Kira are going to be chosen at random in a drawing. They put 3 names in a hat and conduct an experiment with 24 trials. The results of each name getting picked are in the table below. Based on the results, what is the experimental probability of Kira getting picked? B, what is the theoretical probability of Kira getting picked? C, based on the results, what's the experimental probability of Dave or Rachel getting picked? D, what is the theoretical probability of Dave or Rachel getting picked? And then E, we cross off. All right, so do your best. Rewatch the video if you have to. Good luck.